Hello, Math Analysis. Welcome to Lesson 10.2b. We're going to be discussing limits and motion and talking more about area and how this applies to calculus. So before we get too far into this, I do want to do just a little bit of review. We've done sequences and series before, but I just want to bring it back for just a moment because trust me, it's going to come back into play. So I have a few questions for you to try out. These are all review questions. List the elements of a sequence for a sub k that equals k squared, for k equals 1, 2, 3, and 4, and I want you to find the sum. So I want you to list off the elements and then find the sum. I want you to find the sum of this guy, and of course I also want you to answer these two questions down the bottom. So go ahead, hit pause to try this out, and then hit play when you're ready to check your work. So start things off. We're finding the sum for these two. We're not finding the sum for this one. But I do want to list the elements of the sequence. Well, if it's k squared, I need to plug in each one. So 1 squared, 2 squared, 3 squared, 4 squared, which gives me 1, 4, 9, 16. I want to find the sum of these guys. Now, there are a few ways. They did not show their work here, but there are a few ways you could have approached this. This is an arithmetic sequence, so if you wanted to, you could have said, okay, I'm going from 1 to 5, so that's 5 elements, and then I could have plugged in a 1 to get the first one, plugged in a 5 to get the second one, found the average, multiplied by the number of terms. But let's be honest, probably the easiest way to do this is to plug each in. So if I plug in a 1, I get a 2. If I plug in, and then keep plugging in until you get to 5. If I plug in, and actually I don't want to, let me erase that. I don't want a comma, I want a plus sign. It said find the sum, so I'm going to find the sum. So plug in a 1, plug in a 2, plug in a 3, plug in a 4, and plug in a 5. And if you add all these up, you do get 20, which of course was the whole point of this and kind of what we were going for. Same thing here. I'm going to plug in a 1. 1 squared is 1. I'm going to plug in a 2, plug in a 3, plug in a 4, and plug in a 5. Oops, that's a 25. And then, of course, summation means I'm going to add them all together. Yay, and that gives me 55. Car travels at an average speed of 56 miles per hour for 3 hours. We were talking about this yesterday, so you'd have to do 56 times 3, which would give you 168. This one was a sneaky one because it was 4 gallons per minute. But they didn't give me minutes, they gave me hours. So first thing I'm going to do is I'm going to say, okay, well, let's turn my minutes. I get 1 minute. Want the minutes to go away. So 1 minute, pardon me, I'm going to try that again. That should be 60 minutes for every 1 hour. And that makes my minutes go away. And then, of course, we're doing this for 3 hours. Yay! Which makes my hours go away. And then I just have gallons. So 4 times 60 is 240, times 3 gives me 720 gallons. Yay. These summations that we've been doing, they're leading towards something. So we were doing a summation, right? We start with some number at the bottom, we end with some number at the top, we plug it in. Now you'll notice we kept multiplying. Those last two problems we kept multiplying. So I'm going to put times delta x over here because we kept multiplying by something. And notice we plugged it in a 1, plugged in a 2, plugged in a 3, plugged in a 4, all up until I got to the number at the top was the last one I plugged in. And of course, I added all of them together. That's what the summation is for. Here's how this works. You can actually divvy these up into little sub-intervals, all right? You can divvy them up into little sub-intervals. So if I start at 1 and I go until, we'll say, 4, and I said, hey, split that up into 4 sub-intervals. Well, I would split it up into 1, 2, 3, 4 sub-intervals. You could also split it up into smaller sub-intervals. This is your delta x, by the way. These little sub-intervals, the length of these sub-intervals is double delta x. So if I have said, hey, I need 4 subintervals, then I would take these guys here, my interval from 1 to 4, and I would say, okay, 4 minus 1 and divide by 4, right? Hooray for me. If it said divide it into 8 subintervals, then I would say, okay, 4 minus 1 divided by 8. And that'll tell me what my delta x is that I'm multiplying by. And again, in order to get my f of x, we're just going to plug it in, plug in, plug in, plug in until we get to my number of subintervals. And we multiply them together. So we use sigma notation like this. If it's a little confusing, don't panic, don't worry. This leads us to what we call the definite integral. So another way of writing this, we have a nicer way of writing this because this is really super messy. So instead of delta x, we change that into dx. It's just delta is d as a Greek letter d. It's easier just to use a d in English. Let's be super honest about that. And then of course, instead of f of x sub I, we're just going to put an f of x. Here's my function. And of course, we said it had some interval to it from a to b. Then I'm going to turn my summation into like this tall, skinny S guy. And I'm going to put my lower limit and my upper limit of my interval below and above. All right. And this means the same thing as this. So this is an integral. All right. Let me show you how this works. We've been multiplying stuff. What we've actually been finding is what we call the area under a curve. So here's the deal. I'm going to make something up. This could be great. This could be bad. I'm going to go from 0 to 4, and I'm going to have some function, I don't know, let's call it 2x dx. You can solve this by graphing my function, and in this case, my function is 2x. So I'm going to be like, okay, well, my f of x is 2x. And I'm going to graph for the interval from 0 to 4. So my interval is from 0 to 4. Oops, there we go. So here's how I can solve this. I'm going to do an area. Watch this. This is so cool. So I'm going to graph 2x. If I recall correctly, it sort of works. All right, I'm going to use some different colors to kind of help me distinguish this a little bit. So I'm going to graph 2x. Well, it starts at 0, 0, because there's nothing on the end. And I have a slope of 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I believe we're going to do one more, up 2 over 1. And I'm only graphing from 0, 1, 2, 3, 4, to 4. So I've just graphed my function, not my best line ever, from 0 to 4. Now, what the integral is actually asking us to do is it's actually asking us to find the area under that curve from 0 to 4. So from 0 to 4, it's asking us to find all of this area in here. Yay. You can very easily find that area. You know how to find this area. Why? Well, because it's a triangle. Super easy to find the area of this guy. You know how to find the area of a triangle. It's 1/2 of your base times your height. Well, it looks like my base is 4. I go from 0 to 4, so my base is 4. And of course, times my height. Well, my height is over here. If I plug in a 4, I get an 8. So it looks like I will go from 0 all the way up to 8. So 4 times 8 is 32. If you cut that in half, you get 16. You just found out that this integral, this definite integral, I should be specific about that, the definite integral from 0 to 4 of 2 of x with respect to x is 16. Now, another way you could have done it is you could have chopped this into little pieces and added all your pieces together. That's why we have that summation right there. But generally, I find it's a lot easier if I just graph this bad boy. I'm like, okay, I'm going to graph it from 0 to 4, and then I'm going to find the area under that curve from 0 to 4. And boom, there's my definite integral. As always, guys, I hope you found this helpful. I hope you found this useful. If you've got questions or concerns, email me or come see me after school, Tuesdays and Thursdays. You know I'll be around, and I'll see you soon. Bye.